All right, let's take a look at number 24. We're going to be talking about transversals. Transversals is simply a line that intersects two or more coplanar lines at two different points. Okay, so if we have, let's see, two lines kind of going like this, they're going their own directions. A transversal could just be any line that intersects at these two different points. So in this case, this pink one is the transversal. Okay. And the characteristics we'll get into when we talk about this specific example, where instead of just having any two lines, we have two lines that are parallel. And this is really where things get exciting when it comes to transversals, okay, which is this line here that intersects at these different points. Okay, so we have a bunch of different types of angles that have certain qualities to them that we're going to use to solve problems. So let's first go through the definitions and talk about each one. So first we're going to do corresponding angles. Now corresponding means they're pretty much in the same location along each of these parallel lines. So for instance, there's kind of like four different corners for each of these parallel lines, right? We have 1, 2, 3, and 4, and then 5, 6, 7, and 8. So the corresponding angles are the ones that are in corresponding positions for each of these. So one from each of them. For instance, angle 1 is kind of in the upper left corner here. And what is the angle number for the other parallel line? That would be angle 5. So angle 1 and angle 5 are corresponding. Now, of course, there are many of them. 2 and 6 are corresponding. 3 and 7 are corresponding. And then 4 and 8 are corresponding. So they're all in the same location but different parallel line, right? Okay, so that's corresponding. Then we have same side interior angles. So interior, we're going to be thinking about this. It's the interior of the two parallel lines. It's this interior. Okay, so we're talking about the same side in the interior. That means we'll be talking about the same side of the transversal right here in the interior. Okay, so that would be, for instance, 3 and 6. So 3 and 6 are in the interior on the same side of the transversal. So 4 and 5 would also be same side of the transversal and on the interior or between its parallel lines. Okay. Let's see here. Go this one. All right. Then we have alternate interior angles. This is similar to the same side, but on alternating sides of the transversal. So, for instance, angle 5 is still interior, right? And then the alternate side, or other side, we can say, would be angle 3. So angle 5 and angle 3. Also, angle 4 and angle 6. There we go. And then next we have alternate exterior. So very similar to alternate interior, but they're on the exterior. So that would be over here. This is an exterior, or outside, or not between the parallel lines. And this is the exterior. Alternate, so on opposite sides of transversal, but on the outside. So something like 8, angle 8 here is on the outside, and on the alternate side, or the other side on the outside, would be angle 2. We got angle 2 and angle 8, and similarly we have angle 1 and angle 7. Okay, so those are the brief definitions. So if we're just going to do a little bit of naming angles here, so let's look at 1 and 8. Got 1 and 8, right? Remember, this is the, let's do it this way. This is the interior, right? This will be the exterior here and the exterior here. So right away, 1 and 8, you can see, are on the exterior or outside of the parallel lines. So we know this is going to be exterior lines, and then they're on alternating sides. One's on top and one's on the bottom, so that's how you get alternate exterior angles. And I'm going to abbreviate it with alt, EXT, and then angle with apostrophe S. So alternate exterior angles. Okay, then we have 3 and 5. So 3 and 5 are both on the interior, and they're on the same side of the transversal, which is right here. Usually marked with the letter T. So these are on the same side on the interior. So we have same side interior INT angles. 4 and 5. We have 4 and 5, interior for sure, but they're on the alternating sides of the transversal. So here are alternating interior angles. Okay. We have 4 and 8. Those look like it's either on the same side of the transversal. They're not interior or exterior, right? Because we have one on the inside and one on the outside, which means these are corresponding. They're in the same relative position to each other. Corresponding. So you can look at both parallel lines and see that 4 and 8 are both in the bottom right of the parallel line. Okay, let's do a few more. 2 and 6 looks like are also corresponding. They're on the bottom left. They're corresponding. 2 and 7. 2 and 7 are both on the exterior, and they're on alternating sides. So we just got alternating exterior. 3 and 6 are both on the interior on alternating sides. So we have alternating interior. And then 4 and 6, so 4 and 6 right here. So they're on the interior and on the same side, both on the bottom or below the transversal. So we're going to have same side interior angles. There we go. That's good practice naming those. Now we have a few theorems based upon if the two lines are parallel. Okay, so you might already be able to look at these and say, well, there's some vertical angles here, so we know like 5 and 7, 1 and 3 are congruent. But what about for all these different types of angles, these new ones? So for corresponding, if two parallel lines are cut by a transversal, then pairs of corresponding angles are congruent. So 1 and 5 are congruent, 4 and 8 are congruent, 2 and 6 are congruent, and 3 and 7 are congruent. Go 1 to angle 5, angle 2 to angle 6, angle 5, angle 2 is congruent to angle 6, angle 3 is congruent to angle 7, and angle 4 is congruent to angle 8. All right. same side interior. So again, here's the interior on the same side. Now you can see that one is obtuse and one is acute, right? And we could show pretty fast since 6 and, well, how about this? 2 and 3 are linear pairs, so we know that they add up to 180, right? But from our last theorem here, corresponding angles, we know 2 is also the same as 6 because they're corresponding. So that means if 3 is supplementary to angle 2, 3 is also going to be supplementary to angle 6. So if 2, again, parallel lines are cut by a transversal, then pairs of same side interior angles are supplementary. And we can prove that because of the corresponding angles. All right, we got some alternate interior. So we have something like here, 5 and 3. Right, so since 5 is going to be supplementary to 6, and 3 is supplementary to 6, yeah, we know that these will turn out to be congruent, right? Because each of these has to add up to 180. You know, we have to add this angle 6 to both of these and get it to 180. The only way that's going to happen is if both of these have the same measurement. Okay, so if 2, again, parallel lines are cut by a transversal, then alternate interior angles are congruent. And again, that's like angle 3 is congruent to angle 5, and the other pair would be 4 and 6. Angle 4 is congruent to angle 6. Okay, we have one more here. That would be alternate exterior angles. So on the outside, the exterior, on either side of the transversal. So we're talking about 8 and 2. You can see those are both acute angles. So these are, again, going to be if 2 parallel lines are cut by a transversal, then pairs of alternate exterior are also congruent. So there are our theorems. 3 of them are congruent, corresponding alternate interior and alternate exterior, and then the same side interior are supplementary. So let's do a little practice using those, knowing on the back here that measure of angle 1 is 110. So we got 110 degrees, which makes sense. It's obtuse. It's bigger than 90 degrees. Okay. So a measure of angle 2, right? These are a linear pair, right? We know angle 1 plus angle 2 has to be 180, which means angle 2 for this to add 180 needs to be 70 degrees. 110 plus 70 is 180 because they're a linear pair. So we got 70 degrees. Angle 3. Angle 3 is vertical angle to angle 1. Right? So angle 1 and angle 3 are congruent by vertical angles, so this must be 110. Angle 4 is a linear pair with angle 1, so that's going to be 70. It's also going to be a vertical angle with angle 2, so it's 70 there as well. So we can get it from subtracting 180 minus 110 and also knowing it's congruent to angle 2. Angle 5, we can see, is corresponding angle 1, right? They're both on the upper left. So we know by corresponding angles, and that's going to be 110. Angle 6, right here, is you can do a couple ways. It's a linear pair with angle 5, which is 110. That's what makes it 70. But it's also corresponding with angle 2. Angle 6 and angle 2 are corresponding, so it's also 70 that way. Measure of angle 7 looks like it's a vertical angle to angle 5. right? We also know 3 is 110, right? So it's corresponding, 7 and 3 are corresponding angles. That makes that 110. And angle 8. Right? And we can do this, let's see here, how about alternate exterior angles? Right? So we know that they're going to be 70. So that's really what we're doing today, is just kind of getting the hang of this and all these different new terms. It would be a good idea to make some flashcards with everything we've learned from yesterday and today, and to make sure we know which ones are actually parallel, which ones are supplementary, so we do not mix them up later. These are going to be like the times tables of this particular unit in geometry. We have to know all these different types of angles really fast, and we have to know what their relationship is as well. So go ahead and work on the rest of this. Rest of these, go ahead and label each one by name to say what it is, and then also find the measure of all the different angles here. All right, good luck.